Hello, everyone, and welcome to Capture Existing Conditions with BIM's with Scan to BIM Technology webinar. My name is Juliana, and I work in marketing here at MicroCAD. And today's presenter is Mike Russo, our applications specialist. At today's webinar, we will introduce and explore a Scan to BIM with Autodesk and Leica technology. Throughout the webinar, you can ask a question at any given point on the left-hand corner. You can ask Mike to revisit a step or ask any questions. This is your time and we want you to make the most of it. And in the upper left-hand corner, you will find links to our social media, website, and YouTube channel. So we post all of our webinars there in our YouTube channel, so you can rewatch it on your own time or share with colleagues later. So yeah, without further ado, we'll pass it on to Mike. Hey, Mike.
Thank you, Juliana. I'll go ahead and share my screen. Okay. Well, welcome everybody. My name is Mike Caruso. I'm an application specialist on the infrastructure side here at MicroCAD. I typically train and teach Civil 3D, AutoCAD Map, InfraWorks, and also offer custom programming for the same products. But today I'm presenting MicroCAD's geospatial services. We've been working in this area for a few years now, starting originally with some drone data capture and then moving into the scanning services. But feel free to take down my email. This will also be recorded. Reach out with any questions after the meeting. I'd be happy to take those from you. And let's begin. So we're going to talk a little bit about scanning and reality capture with drones as well. But basically what we're looking at is we're trying to use these new technologies to improve the process of capturing data in the real world. Right? So we've done this conventionally with surveying methods. Right? Land surveyors are typically the first ones we call for deed research and property boundaries, and then eventually topography and picking up utilities and so on. And for years, they've used conventional methods of total stations and collecting things by walking around and picking up the features of interest. So what scanning brings to that now is the ability to capture millions of points in a matter of minutes. And so you can see the efficiency right off the gate here that this brings. So we kind of look at this in four major pieces here. So we have this capture process. So whether that's with a scanner, LiDAR technology, or using a drone for photogrammetry, even drones with LiDAR, we need to capture all this information accurately. All right, and so
Hey, Mike, sorry, we got a question, so let me answer that real quick. This webinar will be recorded. We're getting questions about that. So you do not need to worry about it. We will be sending tomorrow the on-demand recording. You can keep going, Mike. Thanks, sure. Sorry.
All right. So the capture involves, these new technologies. We collect a lot of data, and that all has to be stored. Now, the format that it comes in may be a point cloud off of a scanning device or photo images from a drone. All right, but it generally involves a lot of storage and storage management. But then from all that data, we have software services here at MicroCAD to process that data. So how do we take a bunch of photos and then turn that into topography? So we have solutions from Esri and Autodesk and Leica that can help us manage that data and convert that data into 3D data. Point clouds, of course, they come in 3D format already, but it's a lot of point data. And so then we want to turn all that point data into Revit walls and Revit roofs and buildings, all right, and true 3D models. It's in a scan to BIM situation. So we take you through that step as well. And then we have what's the publication step. So the processing of that data into real 3D models, whether that's in Revit or Civil 3D or Inventor, depending on your industry, we have a way to publish to a format that you'll be able to utilize. And then comes that deliverable stage where you consume that data. Now you use it to, build forward or keep it for record keeping and so on. So those kind of the four large pieces. Let's take a look a bit more at the technology portion of it here. So MicroCAD is an authorized Leica reseller. These are some of the devices offered. On the far left, we have the BLK to go, a handheld LiDAR machine. So you can just walk down the hallway and capture doorway entrances, the floor, the ceiling, walls as you walk. We have at the far right, the BLK 360, sort of a stationary version of that. Both of these are great for smaller spaces where you need a quick scan. They don't have the range that the larger pieces do, but they do serve a purpose in smaller environments. So the two scanners in the middle now, we start to look at the Leica P series, the Leica RTC 360. These have more range, and they're much more powerful. They're very fast. Well, the RTC 60 is very fast. We can capture in 360 degrees in about 2.5 minutes. The P series, you're looking a bit longer, right? Like 11 to 13 minutes. And it's some additional setup. But all these devices are available as well through MicroCAD. We use them internally for our own consulting as well. If we have to do data capture requests for clients, we typically use the RTC 360. Very intelligent scanner that actually tracks where you're moving it from setup to setup. So it makes for easy registration of point clouds and then processing. So, so for scanning, we have two main uses. We're either scanning on the inside or the outside. So we have interiors and exterior scans. And so for properties and facilities, which typically falls under your AEC and surveying disciplines, on the interior side, scanning may be beneficial for people in real estate, remodeling, BIM collaboration, because we can capture the internals of the building, the piping, the HVAC, electrical, water, and so on, can all be captured in its current state. And then for people looking to expand, all right, so if we're going to do additions or build on their production line. So these are some of the uses for those interior scans. We see quite a bit of need from architecture as well. It saves them all those interior measurements, that we would normally do with a laser or a tape measure. So much faster and reduces the possibility of having to go back for something that you missed. This, as long as you're not standing in the way of the lens, it's going to capture everything in the room. And then, we move them strategically, based on what we call shadowing. So if there's a pole in the way, we have to move it to the other side, and then we scan a second time. So there's no shadowing going on. But generally within 5 minutes, we have all the data that we need in a room to centimeter accuracy,
Hey,
which
Mike,
is great.
sorry,
Yep.
we have a question.
Oh, great.
Can we capture details of a power plant? Details like piping, equipment, foundation pads, etc.?
Yes, absolutely. There's safety and distance requirements around the power plants, but the range of the scanners can go 1 and even 200 meters. So not a problem to still get that centimeter accuracy and still be able to make some sense out of the scan that's returned. So yes, that is another use for the scanning. Also for power plants, another concern is overheating. So we also offer services from the drone with thermal camera, looking for hot spots, and then also for doing the photogrammetry. So we can basically cover all 3 areas in that regard. But yeah, great question. Another industry that I'll have to add to my slides here.
Thank you, Mike.
Sure. So scanning property interior, and then we have scanning on the exterior where we can use the scanners for exterior applications. It's great. It'll pick up features of the property, manhole locations, electrical boxes. However, when we start to grow in size for the project, we typically fall back to photogrammetry, where we can cover acres at a time, versus a scanner setup, which is only going to get several hundred square feet at a time. So photogrammetry is where we look for exterior, and this types of applications where we would use this is for pre-construction and site surveys. It also comes in handy for volumetrics, so landfills or aggregate companies selling soil and materials that are moving a lot of things around the site. We can actually do daily inspection and do daily comparisons for volumetrics. And then, as I had mentioned, for the power plant thermal analysis, the different payloads available to the drones is just astounding. You can put some really powerful equipment on the drone and use them in a lot of different scenarios. So we have the photogrammetry, we have LiDAR on board, and then we have thermal cameras available, depending on the application. So this has probably been the biggest game changer, as far as the in the surveying world, where you don't have to drudge through sticky marsh and hard to access locations in order to take a shot on a prism. Now we can just send the drone and cover much wider area. Another thing that's been improving on the payloads is the cameras, the megapixel resolution and the sensor sizes are going up while the prices are coming down. So you can actually get into, it's almost hard to upgrade now. If you get into an enterprise level drone, there's not much to improve upon. They're taking great photos, and the data that's coming back is within tenths of a foot total for vertical, horizontal control. So let's look on. Other applications, so outside of, say, AEC, we do see scanning needs around manufacturing and product development areas. So if there's machinery or fabrication floors with machinery that maybe this is for space planning, we can do scans of the manufacturing plant, show you the current situation, and then that makes for easier management of equipment. And if you're going to move things around the shop floor or do a new layout, you've got this current as-built model, and it's much easier to work with. Another case that we had done was scanning equipment and also personal, like boats and anything that's being built that of an odd shape. So it's not rectangular. So we have these odd curves like on yachts and so on. We're able to scan them when they're dry docked and get accurate representations of the hull, whether you're looking for damage or if you're going to retrofit anything to it. Now you have complete accurate measurements for that. So these types of applications generally fall under quality assurance, and then also the reverse engineering or retrofitting of things. We can also use the scanning for that. All right. So some examples, what we've done, you'll see that Size is not a requirement. This is a large gymnasium, and we took the scan. You can see that they did some improvements to the roof superstructure. So we did an existing scan of the conditions, and then over to the right, we see that same scan was brought into Revit. It looks like a real photo. However, that's actually computer generated in Revit using Enscape rendering engine. So we can model all of the pieces and of the gym, the floors, walls, and roofs, doors and windows, and put in even some bleachers to see how those would fit, and then shine up that floor like it was just waxed, and give you the final presentation. So not to say, that quite impressive for your clients to show them what things are going to be, and sometimes the picture just is the 1,000 words that you need to land that contract. So it all starts from the scanning. It'd be very difficult to reach those upper corners of the roof and get true measurements. So the scanner reports back again, centimeter accuracy from as far away as 30 meters. So pretty powerful stuff, and done within minutes. So when we take that scan data, the next piece is that processing portion of the workflow. So we have Leica solutions that go right on top of your AutoCAD or your Revit and let you work with those scans and point clouds much easier. They're optimized for your computer so that there's no lag. It's very, it's easy to work with. You're not waiting for zooms and regens. And then you're able to put in your AutoCAD and Revit native entities on top of the scan. They also have tools in there to recognize certain shapes like pipes and ducts on the BIM side of Revit. And then on the AutoCAD side, there are tools for setting Kogo points over your point cloud surface so you can start to rebuild your Civil 3D topographic surface. So lots of tools are available to make this workflow faster, and these are ever improving as well. So we offer these tools as part of your purchase with a scanner, but we also offer training on these as well to get you up and running. So if this is a new area for most of you, if you don't own a scanner or you don't own a drone, you may be asking, well, when do I start to look at this seriously, or to own it in-house, or do we look at this as a service, that we can go to a third party and have them do it for us. So if we only need this 2 or 3 times a year, yeah, that might make sense. But if this is your industry and you're wanting to stay ahead and do things faster and more efficiently, now maybe you look at acquiring these things. And so these are some questions to kind of think about. Do you use point cloud rendering? What methods are you using to capture it currently? And how much time is spent on reworks? If you have to go back out and remeasure, are you using any scan technology today? Maybe that's become obsolete. Maybe you got to look at upgrading, see what the latest equipment is, and we're here to answer those questions for you. Back to how many times a year do you get scanning services? So again, is it a service that you would hire out for, or maybe you need to have that as part of your assets? And then how much do you spend per project when you do outsource it? That's another thing to consider. So at this point, I think we can open it up for questions. We've got about 10 minutes left, and I'd be happy to take any questions that came out of this. Anything on your end, Juliana?
No, not yet.
Okay. All right.
I have one question here. What are the differences between the Leica RTC scanner and the P series?
Oh, yes, great question. So I'll back up a few slides for that if I can. So here we have pictured in the center the RTC 360, and then maybe the title's cut off, but down below is the P series. So um, the P series has a longer range than the RTC 360, so it can be set up from further away. It can reach higher heights and so on, and it can also do a focused scan where you kind of set the range for it to look at, and it intensely scans that one area. So it's a bit more powerful, has more range, but again, as I mentioned, takes a little bit more time to collect that scan. The RTC 360, um, great for interior work and some exterior, but just a little bit less range on it than the P series. But it does have the benefit that it's very easy to set up and move from point to point because it tracks its location as you move it. Price difference wise, RTC 360s are about 3/4 the price of the P series, give or take, but you pay for that extra range should you need it.
Okay, thank you. We have another question. I don't know if maybe Luis can help us with that, or if you know. The question says, what is a typical charge for scanning per day?
Oh, well, there's probably no one answer for that. It would depend on the site and the deliverable that you would need and the application. But that would probably be best taken if you do want to follow up on that. Reach out to myself or Luis directly at MicroCAD, and we'd be better able to tailor a quote for you around that.
Okay, and next question is, can the scans be imported into AD Inventor?
Scan to Inventor. So there's sort of a missing link there that we would need to convert the scan into some types of solids. So uh, that can be done with CloudWorks on top of AutoCAD, but generally Inventor is better at handling importing of certain models like a step model or a type of solid, and then you can work with it from there. So yes, there is a solution to go from scan to Inventor, but we usually have some middleware in between.
Okay, got it. Thank you, Mike. And next question is, do you have any examples of scans of industrial plants?
So we have quite a large client that we've done regular scans for on the industrial level. However, they're a government contractor, and so everything is very highly guarded. Um, you can check with us after this call if you'd like to follow up. If we can get past any NDAs with some of our other clients, then yes, we'd be happy to share those.
Thank you, Mike. Next question is, what is the maximum time for a scan with the maximum resolution?
For a single setup at max resolution, the RTC 360 is probably around 7 minutes, where the P series would be upwards of 13 or 15 minutes at a max resolution scan.
Okay, thank you. Next question is, can we see a demo of a scan being transformed into a usable AK model? How do components work? Fixtures, outlets, alarms, etc. Is everything just dots?
So yes, I think that would be a great suggestion for a future webinar where we can give you a little bit of a hands-on demonstration of the tools. And
Absolutely.
yeah, definitely on that. And then, yes, certain applications are better suited because they have libraries of parts and families like Revit. So, the scans aren't automatically recognized, but for certain shapes they are, like piping and ducting.
Okay, yeah, I think for those requesting demos, that's a great idea, Mike. I think we can do another webinar where we can cover that. But yeah, as a reminder for everyone, If you want to learn these topics in detail, you can always contact us, Mike, Luis, or I, and we will get you up and running. So yeah, be sure to be checking the MicroCAD website for future webinars. I don't know if Mike, if you have anything else.
No, if that's all the questions, then I'd just like to say thanks for everyone attending.
Okay, and that will be all for today. Thank you everyone for attending, and thank you, Mike, for that wonderful presentation.
Thanks, everyone.
Thanks everyone. Bye bye.